Hello, what is going on, my fellow omnivores? Today I'm going to be building my much anticipated...
Much anticipated by who?
By them, the people that watch my...
Well, I think you should stick to what you do best.
And what would that be, Grandma?
Making sandwiches. You sissy.
Well, now I think you're just being sexist. Isn't it past your bedtime? Jesus. So this week I will be diving deep into the world of brushless DC motors. Specifically, I'm going to be building my own. And for parts, I'm going to be using N-channel MOSFETs and then P-channel MOSFETs, also known as the red-headed stepchildren of transistors, because they will burn your house down. I'm also going to be using Hall effect sensors, optocouplers, and of course the Arduino Uno. Now I know half of you are probably thinking, what even are these parts, or how is this all going to work? Well, I'm going to explain everything in great detail after Sophie rolls the intro. Where do I even begin? I need more caffeine. So I'm going to start off by drawing the three-phase motor here. So these are going to be coils A, B, and C. And these are going to be A prime, B prime, and C prime. So here are these 6 coils and these 6 transistors, which I'm going to get back to later. But important thing number 1. So all of these ends, B prime, A prime, and C prime, need to be tied off together. And important thing number 2 is that we want each of these pairs of coils to be opposing each other. So let's take A and A prime, for example. If A is clockwise, A prime then has to be counterclockwise. So let's say we feed current through A, and its magnetic field produces a north side over here. We want A prime's magnetic field to point north in this direction too. And I'll come back to why both of these points are important in just a second. So in a motor like this, there are normally 6 steps. And I'm just going to reconnect. I'm going to draw this node up here so it's out of the way. So for this next thing, I'm going to be explaining the phases of the motor and what this thing does when it turns on. So I'm going to draw the magnets in here too, just for better representation. Okay, so I wrote all the steps over here. So step number 1 is A, C prime. So positive current is going to go into A. It is going to flow around A, go through A prime. So when that happens, north field is going to point this way, north field is going to point this way. It is going to go out of A prime, go to the node where all of the primes are connected, and then go into C prime. And then because it is oriented in an opposite direction, it is going to have south-facing fields this way, and then it is going to go through C and have a south-facing field in this direction too. And then it is going to go right to ground. So basically through each step, one of these pairs is going to be south with respect to the magnet itself. The magnet is going to see a pair being south, a pair being north, and a pair just being off. So this is really convenient because now we have a way to literally just drag these magnets around in a clockwise rotation. Okay, so now let's talk about MOSFETs. So this layout is actually really simple. So up here we have P-channel MOSFETs, and then down here we have N-channel. So let me first mention, A, B, and C are the only connection points here. C prime, B prime, A prime, they don't connect to the transistors at all. So what we have here is basically A, B, and C connected to both the high side and the low side of the circuit. So when A wants to turn on positive, you activate the P channel. And when you want A to be negative and suck out all the current going through, you want the N channel to be activated. So let's say we have the first step. So A and C prime. So now we want A to be high and we want C to be low because we want current to go in and then current to go out through C. So what we would do is open the P channel and then open the N channel of the C MOSFET. And what that would do is send high current through A and suck out all the current through C. Alright, so now that we're done with MOSFETs, we can talk about Hall effect sensors. And they're basically just logic level devices that send signals back to my Arduino when they detect a magnetic field. So I'm going to have one at A, B, and C, and it's going to be pointed inwards so it can detect when this thing moves around. Hall effect sensors pick up on north sides of a magnet. So when it senses the north side of a magnet, it sends a low signal to my Arduino, and when it senses the south side of a magnet, it sends a high signal. So my Arduino can change these values to zeros and ones. So as you can probably imagine, depending on where this thing is and which sensors it hits, it can send a different sequence back to my Arduino, and that can look like 010, 101, blah blah blah. And there is actually a sequence that goes along with this thing's rotation, and that is how we can set up the timing of the motor. So these are the 6 different signals that are going to be sent back to my Arduino from the Hall effect sensors. So let's look at 100. So that means that A is going to be high, B and C are going to be low. So A is going to be looking at a south magnetic field. B and C are both going to be looking at north magnetic fields. That was a lot, I think. But the last point I'm going to make is why we need the optocouplers for the Arduino. So these coils are going to be drawing a lot of current relative to the Arduino, which uses, I think, 5 volts or 12 volts on the input. But the Arduino is relatively delicate circuitry compared to what we are using for the coils. Alright, quick analogy here. Let's pretend that you are a mother that just witnessed her idiot 4-year-old come out of the bathroom with a handful of his own poop, and he plans on finger painting. You, hopefully getting to your son in time, would be the optocouplers in this scenario. Your idiot 4-year-old would be the high current, and your white bedroom walls would be the Arduino. What I'm saying is, if the high current reaches the Arduino, it could be catastrophic. So let's start building this thing. Damn it, Sophie! Jesus. Same. Okay, that's fine. Now we just gotta line her up. Alright, so I finally have this thing all set up. I got the N and P channel MOSFETs, the optocouplers, the sensors all set up, the code is correct. So, let's test this thing out. I'm going to do 30 volts at 4 amps. I don't know if you guys can tell how fast this thing is going, but it is going insanely fast. I can literally feel the desk vibrating. That is insane. This thing... Honestly, that was crazy. That blew my expectations away, first of all. I never thought it would go that fast. That was crazy. For the code being so simple, like literally like 5 lines of code, that was insane. The RPMs, I don't know if you guys could see that. That was way, 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 way faster than my brush DC motor, or just more quiet. I don't know. But that was crazy. Thank you guys for watching as usual, and I will see you in the next video.